Dr. Knag, what do we do today?
Dr. Bilo, we're going to see Dr. Seel. Dr. Seel is Matthias Seel. He holds a PhD in the structural use of glass. Is one of the glass freaks. He's a postdoc at the Institute for Structural Mechanics and Design in Darmstadt, and is running the glass research group. He's going to be leading the Glass Competence Center in Darmstadt.
So today, all about glass.
All about glass.
Today, all about glass. See you soon. Hi.
Okay, this is the facade. Keep this for a minute. Keep this.
Thanks, Uli.
No. I need to place the post-its. Post-its have to find their place. Now this is post-it number 1. Question package number 2. Question package number 3. Yeah. I'm gonna fix them because okay. Let's now talk about the content which we place on the post-its. Glass for facades, function, transparency, IGU. So, what is the function of glass in facades?
Okay, for facades, it's a cladding, and you have with this cladding, with the material glass, the possibility that you have transparent cladding, and it saves also for environmental things like rain from the outside, like the temperature and UV and so on. And so you have a nice shape and no energy loss from the inside. Also this is the function for glass. And here's the main function. Here's the transparency for glass.
Okay, so it's a barrier like metal, like solid structures, concrete, but it's transparent.
It's transparent. This is the main difference from the other.
That's the main difference. Okay, and then IGU. What is an IGU?
IGU is an insulating glass unit. So normal glass is very bad for heat, loss of heat from inside to outside.
One layer of glass.
Okay. No, it's not only. It's 2 layers of glass. You see 2 layers of glass, and there's a cavity inside, a hermetic closed cavity, so that there's a gas inside, argon, for example, and on the edges it's fixed together with a sealant. And so there will no exchange from the gas inside to the outside, and so you can save a lot of energy inside this glazing. And the U value, I think the U value is much better. It's 12 times better than for normal glass.
It's not just 1 layer of glass. It's actually 2 layers of glass with a cavity inside, which is sealed.
Which seals around the edges.
Which is sealed around the edges, which is what we see in this area.
Yeah.
Okay.
Yeah. This is double insulating glass. There are also triple one. Okay.
That's what I was wondering. There
okay.
are also triple one, which means then 3 layers of glass.
These are 3 layers of glass.
Why do they do that? Why?
To save more energy.
More energy.
So it's the performance, the insulating performance is better. It's factor 2.
And can I just increase the size of this cavity? Does that help?
Not really. Not really. One thing is you have a big pump effect. You have volume inside, and when it's heated up outside, the gas expand, and you see.
This is when I see the buckled glass planes.
Yes.
Okay.
This is not so good, and you need very wide substructure for such big glass panes.
I see, and that doesn't fit for the stick system, for example.
Not really.
Okay, let's go to the next field. Material properties. What is glass? How is glass made? What is it? What is the material glass is made of?
Okay, you need sand, also special sand, silica sand. Then you need lime and soda, and you bring it together, mix it in the right composition. Heat it up with over 1,600 degrees, and then you will get more or less glass.
But that's a fluid then.
Yeah, it's more or less in this case a fluid. Then it's cooled down, and then it become solid and transparent. And it's a amorphous material which is very brittle, like a ceramic. I think you know it from the school or when the glass goes
When you break a piece of glass, yeah.
This thing is for one thing it's good, for the other thing it's not so good. The brittle behavior, as a brittle, it's also very stiff in comparison to it's stiffer than concrete and stiffer than wood, but not so stiff like metal, but it's in between in the range of aluminium. And the brittle behavior is a problem because if it breaks down, you can have injuries with the glass pattern. They are very sharp. And so we have to solve this problem a little bit. So we come to the laminated safety glass or laminated glass. Here we have two panes of glass. You stick it with polymeric interlayer together.
So it's plastic foil.
It's a plastic foil. You stick it together, and when the glass is broken down, it sticks on the foil, and you have post-breakage behavior, and no glass come very fast down from the facade, and you have not a problem for some injuries that the glass come down and you have a cut, for example.
This is laminated glass. And what about pre-stressed glass? What is pre-stressed glass?
Okay, the normal strength of glass is, the characteristic value is 45 Newton per square millimeter. And for some cases it's not enough, so you have to carry out the construction with more thickness, but you want to save also weight and save some glass material, and so you can pre-stress it. Normally for the civil or for the architecture terminal toughened glass. You quench it. You bring glass over the glass transition temperature, 100 degrees above, 630 degrees, and then you quench it very fast with cool air.
Okay.
And then the outside.
That's kind of a shock, huh? So
shock.
You start to boil it and then you shock it, okay?
Yeah, it's not boil. Okay.
Yeah.
It's more or less not really solid, but it's a little bit liquid. And then you quench it, and then the outside will become solid, and the inside is fluid, more or less. And then after some time, the inner core comes together and pre-stress, and the outer material, the outer surface.
I see.
And so you have the compression.
So the outer surface is under
compression.
Compression. Okay. That's pre-stressed glass. Material properties. Glass as structures. What happens when I say lean against this? Why doesn't it break? When I say really get the total. Yeah, the body mass as impact.
This is not. It can be a problem, but if designed for this case, you have. I said you have a strength there, a material strength. For the normal strengths are 45, and if you have your pre-stressed glass, you have 120, for example, for fully tempered glass, and so you don't have a breakage there because it's strengthened the glass. And in case of breakage, you have also a laminated glass. So this is not a problem. And this is one payload. And there are other payloads like normal wind for overhead glazing, some snow, for example. These are the normal payloads.
Okay.
And then
structural loads.
Okay. Structural loads. You see this a big IGU here. He has also have the self-weight, and the self-weight goes in the substructure from all over the glass surface up to the bottom.
Okay. Okay.
And there are two brackets there on the left and on the right side, not so far from the corner edge, and so the total weight comes to the substructure here and goes down in the ground.
As I see this being quite a solid piece of glass, can I use it for a main structure?
Not a solid one, but you can use it also for a main structure, like some beams or girders. You have use also laminated safety glass to stick it together. When one thing is break, it's not bad because you have another one, and there are in most cases more than 3 of such glass panes together with the normal interlayer.
So there are these 3 layers of glass, pre-stressed, laminated, and then I have a kind of solid beam of glass.
Yeah, and also the other crack pattern also transfer the loads.
So if one breaks, the other 2 still take the load.
Yes.
If 2 break, the third one still takes the load.
Yes.
Okay. And then I can build say fully transparent structures.
You see it in the Apple stores, for example.
Right.
Also this is possible.
Now let's take the samples which we just got. So, IGU. This is an IGU.
Yes, you're
We talked about 2 layers of glass and spacers.
Yes.
Explain what it is, how it works.
Here you see the sealant, the outer sealant. This is the secondary sealant, the structural sealant between the 2 glass panes. Here you see. And this transfer the loads from one pane to the another. And there's another sealant here. This is for the water and also the gas inside here. This is the main seal for the function of the isolating glass.
So this really seals airtightness.
This is airtightness.
Yes.
Yes,
And
more or less.
this is structure.
This is only structure.
I see. Okay.
And there's the cavity inside, and there's also a spacer out of stainless steel, aluminium, or polymeric. Here it looks like stainless steel, so that you have a space between the 2 panes. Normally it's 16 millimeters.
And can you say a word about these punched holes?
There are some holes. There is a trying medium inside. If there comes some water from outside to the inside, so it comes to this medium, to the try medium. It's a gel, and so the water is collected there. So
absorbed. So any humidity which gets into the cavity is then actually absorbed in the spacer.
yes,
And if the spacer is having absorbed all the water which it can absorb, then there
there will be fog inside.
okay, and then we see that they're somehow getting blind.
This is the problem.
This is what we see after 20 years in use. Some of them may get blind by having some leakages.
Then it's not insulating glass anymore. It's gone.
then it's 2 layers of glass, and
yeah.
that's it. Okay. Thank you for showing us. Thank you for explaining how glass works and how an IGU works and what performance parameters are.
Thank you for the invitation.
You're very welcome. You're very welcome.
Have fun, guys.
Thanks, all the best.